Assalamualaikum and hello to all. We are going to study chapter 3, Alkenes, structure of alkenes and nomenclature of alkenes. So at the end of this lesson, you should be able to describe alkenes as unsaturated hydrocarbon with general formula CnH2n for aliphatic alkanes, and nomenclature for chapter 3.2. You should be able to draw the structure and name the compound according to Iupac for straight chain, branch alkenes and cycloalkins. For alkenes, you don't have to name the dienes, but you are going to know about cis and trans isomer. Okay, next, general formula for alkenes is CnH2n. N must be larger than 2 because for alkene you need to have double bond. So double bond, it must be between carbon and carbon. And this is unsaturated hydrocarbon. Carbon-carbon and double bond, actually one bond of this is made up from one sigma bond and another one is from pi bond. If shown in a structure, it will be like this. So this is the sigma bond. So at the center here, this is the sigma bond and this is pi bond. Even though it is shown by 2 pi labeling here, actually it is 1. Okay, 2 pi bond that is shown there refers to only one bonding. Okay, one pi bonding, because actually pi bonding is formed from a side to side overlapping of orbital. So when we draw, so this is the general structure for alkenes: carbon, carbon, double bond. And also due to the presence of the double bond, you will see restricted rotation. Okay, means that this one is not easily rotate. A and B here cannot be easily rotate, and because of that, you have cis-trans isomerism. Cis-trans isomerism. Okay, so let's see cycloalkane. What about cycloalkins? Cycloalkins, the general formula is CnH2n plus 2, negative 2, minus 2. It is isomeric to actually alkynes. Alkynes is triple bond. So this is the structure for cyclobutene, which have 4 carbon. And actually it is isomeric to alkyne. Okay, this is alkyne. You can see that there is triple bond. Okay, with the same general formula. And these two, it means that cycloalkanes is isomeric with alkynes. Functional group isomerism. There are some older names for alkenes are still in use. For example, Iupac, it is ethene, but sometimes also called ethylene. Iupac, propene, but sometimes also called propylene. 2-methyl-2-propene Iupac. Old name is isobutylene. And Iupac 2-methyl-but-1,3-diene. This one are called isoprene. Okay, so how to name the alkene using Iupac nomenclature? So the first thing, you need to determine the parent name by selecting the longest chain with double bond. When the chain contains more than 3 carbon atom, numbering is needed to determine the location of the double bond. The chain is numbered starting from the end that is closest to the double bond. If the double bond is closest on the right, you should start numbering from the right. If it is closer to the left, you should start numbering from the left. After that, you indicate the position of the substituent by following the numbering that you have stated earlier in step 3. Okay, so let's see. So let's try to name this structure. Okay, so let's see this structure. Okay, so you can see that this is the longest chain. Okay, this is the longest chain, and the double bond is at this part. So we should label or number the carbon according to the closest end where the double bond exists. So it means at this part. So on the right, on the left, 1, 2, 3, 4, 5, 6. And this is 6 carbon atoms. So 6 carbon atom, the name will be hexene. Okay, hexene. And you need to label the position of the double bond. The double bond is bonded between carbon 2 and carbon 3. You don't have to put the number 3. You just put the number 2. So it means that we have 2 hexene. Okay, 2 hexene. And then you need to determine the position of substituent. This is chloro at carbon number 4. So this is chloro. And this is methyl attached at carbon number 5. So 5 methyl. So 5 methyl. According to alphabet, this one is first and then this one. So the name for this compound is 4-chloro 5-methyl hexene. Okay, so let's see the answer. Okay, so the same, 4-chloro 5-methyl to hexene. 4-chloro 5-methyl to hexene. So that is the proper answer for it. Okay, what about this one? The longest chain. Where is the longest chain? Okay, this is the longest chain. Okay, this is the longest chain. Okay, this is the longest chain. But what about the double bond? Is it closer to the right or closer to the left or closer to the right? So 1, 2, 3. Okay, the double bond we can see at carbon number 3. If we start from here, 1, 2, 3. Okay, so now you have the same position of the double bond whether you count from the left or from the right. So what's next? You need to determine the substituent, the first point of difference. So if you count from the right, the first substituent that you see is at carbon number 1. If you count from the left, the first substituent that you see is at carbon number 2. So this is what we call the first point of difference. So 1 bromo or 2 methyl. So we choose the lower number of first point of difference. So this one. So we are going to choose the numbering 1, 2, 3, 4, 5, 6. Okay, so I will erase everything else. So this one we are not going to use the numbering anymore. Okay, so we are not going to use that numbering anymore. So this is still hexene. Okay, hexene. Where is the position of the double bond? 1, 2, 3. So at carbon number 3. So 3 hexene. 1 bromo. Okay, so this is 1 bromo. So this one now, methyl, has become 5 methyl. According to alphabet, we should write down bromo first. So the name for this compound will be 1 bromo 5 methyl 3 hexene. Okay, so let's see the answer. Okay, the same, 1 bromo 5 methyl 3 hexene. Okay, so that is how you are going to name the alkene for aliphatic. This is aliphatic. Okay, next, what about stereoisomeric alkenes, cistran, the cistran isomer. So what is cistran isomer? When alkene is drawn, you see the compound is on the same side, we label it cis. If it is on the opposite side, we label it trans. But how are we going to see this? Okay, let's see these two example. We have chlorine here, chloro. So chloro here, you can see that it is on the same side. Okay, if you divide this by 2, it means that this is on the same side. You need to divide by 2 across the double bond. Okay, so you can see that this one is on the same side. So when it is on the same side, this is actually cis. Okay, same side is cis. And again, this one you cut a line across the double bond. Do not cut it like this. That is a cross. We do not cross. We cut along the double bond. Okay, so you can see that chlorine here is on opposite side. Okay, one is on the top, one is at the bottom. So this one is trans. Opposite side is trans. Opposite side is trans. So let's see example for this one. So we can see that this is two carbon atom, ethyl. Okay, this is also ethyl on the opposite side. Okay, you put a line here, and Br also on the opposite side. Okay, opposite side. Okay. So based on this, the naming is still the same. You need to find the longest chain. So for the longest chain, the alkyl that have the longest chain is this one. Okay, this is the alkyl that have the longest chain. So again, are you going to label the carbon from here 1, 2, 3, or is it from here 1, 2, 3? So as you can see, it is the same thing. It is the same thing whether you count from the right, from the left, or from the right. And bromine, you also find it at carbon number 3, and this one also you find it at carbon number 3. Okay, the same thing. So actually, whether you count from the left or from the right, it does not make any differences because this is a symmetry structure. Okay, so let's just choose one numbering. We choose like this. Okay, 1, 2, 3, 4, 5, 6. So this one is hexene. Okay, because 6 carbon atom, it is hexene. And the double bond is at carbon 3 and 4. When it is 3 and 4, we choose the lower number. So this one is 3 hexene. And bromo at carbon number 3 and at carbon number 4. So this one, if you group them together, it will be 3, 4, right? 3, 4 dibromo. Do not forget the word dibromo. So this is 3, 4 dibromo. Okay, is this correct? Almost, but you need to remember this is actually opposite group, opposite side, right? Earlier we are talking about cis and trans, so this is actually trans 3,4 dibromo 3 hexene. So that is the proper naming for that one. So trans 3,4 dibromo 3 hexene. So that is the name for the structure. Okay, one more. What about this one? Longest chain. Longest chain is like this. So carbon number 1, carbon number 2, carbon number 3, carbon number 4. This is identical whether you count from the left or from the right. It is identical. And bromine at carbon number 2, bromine at carbon number 3 for the next one. So this will be, for carbon atom is butene. Butene, the double bond at carbon number 2 to butene. So this one will be 2, 3 dibromo 2 butene. Okay, is this finished? Not yet, because again we are talking about cis trisomer. So this is on the same group. So Br and Br is on the same group. So this one is actually cis. And this one, same thing, same compound but different arrangement of atom in space. So this is actually trans 2, 3 dibromo 2 butene. Okay, so that is cis, and this one is trans. Okay, why is it trans? Because this one is opposite. Why is this one is cis? Because this one on the same group when we cut along the double bond. Okay, the same thing. This one we cut along the double bond. This one is opposite, so it is trans. In terms of physical properties, cis isomer, this one cis, cis, it have higher boiling point. Reason, it is polar molecule and trans is non-polar. So you can see that if I draw in terms of the structure, maybe it will be like this. Okay, you can see that these have bigger electron cloud compared to at the bottom here. So this one is partially negative, and at the bottom here is partially positive. So cis is a polar molecule and trans is non-polar. So cis should have stronger van der Waals forces between the molecule, so higher boiling point. Higher boiling point because you need to have higher energy to break the strong intermolecular forces that exist between the cis molecule. Okay, one more example. This one, you can see there is no other substituent, only carbon and hydrogen. Is this possible for you to have cis strong isomer? Yes, still it is possible. So again, you can see that this one is on the opposite side. So this one will be trans. What compound is this? 1, 2, 3, 4. And at carbon number 2 is the double bond. So this is 2-butene actually. And it is opposite side, so trans. Okay, this one cut along the double bond. So this one on the same side. So this one is cis 2-butene. I hope you pronounce cis correctly. This one is not cis. It is cis. Okay, cis is different thing. So trans 2-butene and cis 2-butene. Cis isomer has a higher boiling point. Reason, alkyl group is electron donating group. So cis is polar. Again, the same discussion. Cis is a polar molecule and trans is non-polar. Cis isomer have stronger van der Waals forces and higher boiling point. Okay, what if you have more than one double bond present? So it will be diene. Okay, diene. Diene referring to two double bond. So for example, this one, the same concept. Determine the longest alkyl chain first. The longest chain that contain the double bond. So this one. So are you going to count from the left? 1, 2, or from the right? 1, 2. So it is similar. But you can see that this is chloro. This is chloro and this one is methyl. According to alphabet, C will be first, right? So better you choose the labeling from the left. Okay, so I delete this one. So 1, 2, 3, 4, 5, 6. And this one is diene. Okay, diene. And the position of the double bond is at carbon number 2 and carbon number 4. Even though it is at carbon number 2 and 3, we choose the lower number. So number 2. And this one 4, 5, right? The double bond is at 4, 5. So we choose the lower number, which is 4. So the parent chain name is 2, 4, hexadiene. So you put the word diene there, hexadiene, referring to there are two double bond at position number 2 and position number 4. And chloro is 3 chloro and methyl is 4 methyl. So the full name for this thing is 3 chloro 4 methyl dash 2, 4 dash hexadiene. Okay, so is it correct? 3 chloro dash 4 methyl dash 2, 4 hexadiene. Okay, so this is how you are going to name if it exists more than double bond present. So this is step 5 actually. So still remember, you need to still remember the chapter step 1. Determine the longest chain with the double bond. Okay, follow the step carefully and you should be able to nomenclate alkene. Okay, what about cycloalkane? Okay, for cycloalkane, for example, this structure, you should number the carbon atom with the double bond. Okay, this is the carbon atom with the double bond with number 1 and 2. And in direction that give substituent that you see first with a smaller number. Okay, for example, you can count 1, 2, right? Or 1, 2. Okay, you can go like this or you can go like this. Okay, counterclockwise or clockwise. So which one you want to choose? So it depends. The substituent should have lowest number. So if you choose this one, 1, 2, 3, you have 2 substituent here. And if you choose this numbering 1, 2, 3, you still see substituent at carbon number 3. But this is only one substituent, whereby at the counterclockwise position, you have 2 substituent. Okay, so you need to choose the lowest number of locant So we are going to choose the counterclockwise. So we choose this one. So let me just erase this one. Okay, so this one is no longer 3. So 4, 5. For the cycloalkene, you don't have to label the position of the double bond because it is always at carbon number 1. Okay, so this one is, parent name is cyclopentene. Cyclopentene. Okay, cyclopentene because 5 carbon atom. 1, 2, 3, 4, 5. 5 carbon atom. Substituent that you have is methyl, 3 methyl, 3 bromo, and 5 methyl. So this is same group. This is same group methyl. So according to alphabet, you need to write down 3 bromo first. So 3 bromo dash 3 5. Do not forget dimethyl cyclopentene. So that is the name for this compound, cycloalkins. For cycloalkins, you don't have to determine the diene, just for single double bond. Okay, so let's see. Okay, so it is correct. 3 bromo, 3 5 dimethyl cyclopentene. So make sure everything must be correct. If you miss out the dash here, you are wrong. If you miss out the comma here, you are wrong. If you put a space between here, you are wrong. So make sure everything that you write down is almost exactly what it is written like this. Okay, it should be written like this. Okay, so that's it about chapter 2.1 and 3.1 and 3.2 nomenclature. So good luck.